Hi everyone, this is Amara Rashid online math class. Today is the third lesson for trigonometry. We are still discussing trigonometric identities. I think the first video was all about for trigonometry. The first video was about the basic trigonometric ratios and the inverse of those three basic trigonometric ratios. And the second video was about the fundamental cases of trigonometric identities, where we prove some identities. So today we want to go a bit further and see how best we can go with the trig identities. Okay, want to prove the following. The first one says cot square theta is equal to cosec square theta minus 1. All right, we want to prove this identity. So for beginners, it seems like it's difficult, but just be patient and be attentive, then you'll be able to capture everything. And if you are interested in copying, then you can pause the video, then you can go along and copy. Go on and copy. So now I keep saying there are three ways basically we can prove an identity. The first, consider the left-hand side, simplify, manipulate using every mathematically accepted principles in order to get what is on the right-hand side. The same way, for the second way, you can consider the right-hand side, you simplify it, every manipulation, as long as it is mathematically accepted in order to get the left-hand side. The final way is to solve the two sides simultaneously on the way until you are able to see two equal sides. Okay. Yeah, I'm not saying these are not equal. These are not equal. So these are equal. They are the same. Once we say this equal to this, it's an identity. This is identical to this. Okay. So in that case, being that this and this are the same, but according to what our eyes are seeing now, it's like they are not the same. So what I was trying to talk about, the third method is you solve the left-hand side, the right-hand side simultaneously until you are able to see the same thing. But the approach I want us to look at here is that proving this one, we have one of the most, let me say, the most paramount identity, which is, now let's say, using sine square theta plus cos square theta is equal to 1. I always say that we have over 1,000 trigonometric identities, but for the fundamental and the basic aspect of trigonometry, we have very, very limited number. Yeah. So, but of all the identities so far we have in trigonometry, all of them are coming from this one. Okay. So in that case, let's see how we can prove that this is equal to this using this. The first thing you need to do is ask yourself, what is cot equal to? Let's forget about the square. What is cot equal to? Well, cot is what? Is cos over sine. Cot theta or cot of any angle is equal to cos of that angle over sine of the same angle. So if cot is cos over sine, why considering cot? Because we have cot here. So if cot is cos over sine, it tells us that cot square is equal to cos square over sine square. So our denominator is what? Is sine square theta. So we use sine square theta to divide through. So here we say sine square theta, say sine square theta, then again sine square theta. So what is sine over sine is 1. Any value that divides the same value, we always get 1 plus cos square over sine square. Cos square over sine square is cot square. So we have cot square theta. 1 over sine square. In our first video, I labeled lesson 1. Suppose you have not seen it, go there and watch the video. You will find out that 1 over sine square is what? Is cosec square. Is cosec square theta. So if it is theta, is a theta. If it's sine square x, is cos square x. But this is what we want to see. So we are in cot square is the subject of the relation. So we write this one, cot square theta. The rest go to the right hand side. But on the right hand side, we have cosec square theta. Cosec square theta. So we move this to the other side. It goes with what? Minus 1. So I think this is all what we are asked to show. Okay, so let's go to the second one. The second one says, show that or prove tan theta is equal to the root of sec square theta minus 1. We want to prove this identity. We can as well use the paramount trigonometric identity. So we say from sine square theta plus cos square theta is equal to 1. This is what we want to prove. This is what we want to show. Proving means most cases like this to make sure that we are able to see this. This is identical to this one. Okay. Now, but what is tan actually? What is tan? Tan of any angle is equal to sine of that angle over cosine of the same angle. So if tan is sine over cos, and we want to show that tan is equal to this, what is our denominator? Our denominator is cos. So we divide every term by cos. But we cannot just say cos because there are squares everywhere. So we say cos square theta. Here again, cos square theta. And finally, cos square theta. How do we know the particular ratio we use to divide? This is tan, and tan is sine over cos. So the denominator is cos. We use cos to divide. But why not just cos? Because the relation we are using, there are squares. So we deal with cos square. And remember, if there is no square, there must be no squares. If there is a square, there must be squares as well. Okay. Now, but what is sine square over cos square? Sine square over cos square is tan square. So this gives tan square theta. Division of the same values is always 1. So what is this? 1 over cos square. Our first video, there we discussed trigonometric inverse of trigonometric ratios. So you will find out that 1 over cos square is sec square. This is sec square theta. So 1 over cos square is sec square. 1 over just cos is sec, just that. If it is cube, there must be cube. No power, no power. That's how it happens. Not this one we want to show. This is what we want to show. So we are in tan stands alone. So let's allow tan to stand alone. So what do we say? We say tan theta. Everything has to go to the right hand side, on the right hand side. But on the right hand side, there is sec square. Oh, sorry, there is a square here. On the right hand side, there is sec square theta. This one has to go to the right hand side, minus 1. We are yet to see what we want. So there must be no square, just this one. But from indices, we learned that if x square is equal to a, once you ignore this square and write x, there must be a square root on the other side. That is what we learned from laws of indices. Okay, so in that case, once we ignore this square, what happens on the right hand side? There must be a root. So that is sec square theta minus 1. So now we can see what the question requires to show. Okay. If you are interested in copying the note, you can pause the video, then you can copy because we want to move on and prove the remaining two. Okay, so we have 3 here. We want to show that cosec theta is equal to 1 over sine theta. In fact, these are the inverse trigonometric ratios we discussed in the first lesson. Yeah. Okay. So we want to prove this one. Again, we can use the same by saying sine square theta plus cos square theta is equal to 1. Mind you, there are different ways we can use to prove an identity. If you are already familiar with the identities, you cannot even start from here. You can start from certain identities that say, like, for example, cot square is equal to this. So if you want to prove an identity that contains this, you can even start from there. But for the sake of beginners, maybe some people are beginners, they want to get every bit of it. The reason I keep starting from the same um, Pythagoras related trig ratio. Okay, relation. So the next thing is we want to prove that this is equal to this. But what is actually cosec equal to? What is cosec? Cosec is 1 over sine. So we divide every term by what? Sine. So we divide here by sine, here again, and here again. But the thing is, there are squares everywhere. So since cosec is 1 over sine and cosec square is 1 over sine square, then we can use the one with the square. Very, very easy. So when we divide a value by the same, we always get 1. Cosec square over sine square, what do we get? We have cot square theta. There is already a relation. We did that one, okay, which is equal to 1 over sine. We want to prove this one to be 1 over sine. Okay. So what we do, let's don't bring something new. We don't need to bring something new. So what do we do here? This gives us 1. So we keep saying sine square theta. Oh, sorry. Cos square theta over sine square theta, which is equal to 1 over sine square theta. But what is 1 over sine square theta? 1 over sine square theta is already cosec square theta. Yeah. 1 over sine is cosec. 1 over sine square is cosec square. If there is a square, there must be a square. If there is no square, there must be no square. Okay. But see what we want to prove. Where cosec is the subject. So we hold on to this. Cosec square theta is equal to 1 plus cos square theta over sine square theta. We can gently give this a denominator of 1. So we say cosec square theta is equal to, what is the LCM here? The LCM of any value and 1 is the value itself. So we say sine square theta. So 1 into sine square theta is sine square theta times 1 is sine square theta. Any value into the same value is 1. 1 times cos square is cos square. Okay? We keep going. All we want to see in the end is this equal to this. Okay. So now we say cosec square theta is equal to, what is sine square theta plus cos square theta? Sine square theta plus cos square theta is equal to 1. So the numerator here gives us 1 over sine square theta. So this can be written as cosec theta all to the power of 2. Remember, 1 has a power of 2. Sine has a power of 2. So we say 1 over sine theta. Both the numerator and denominator have a power of 2. So now one term equals to one term. In algebra, my first video in algebra, I discussed about terms, how you can identify terms, what separate terms. Okay, so cosec as a one term squared equals to one term squared. So from exponential equations, this takes away this because they are the same. So we are left with cosec theta is equal to 1 over sine theta. So finally, we have arrived at where we are requested. So this is the proof of what we are given. So finally, we want to go to what? Sec square. If you are interested in copying, you can pause the video, then you can copy it. All right, so let's go to the fourth one. One good thing about online classes, you can keep repeating the video if you want to get the message clear. Or you go to the comment section, then you can ask a question. So the fourth one says, we want to show that sec theta is 1 over cos theta. We want to prove this identity. So the same thing goes, we can use sine square theta plus cos square theta to be 1. Okay. But this sec is equal to 1 over cos, where the denominator is cos. So since there are squares here everywhere, we divide every time by cos square. Why not sine square? Because the denominator is cos. So we divide every time by cos square theta, and cos square theta. So, but what is sine over cos? Sine over cos is something else, which is tan. But what we want to prove, there is no tan. So bringing tan is like bringing something new as a burden, which we need to later digest again. So we don't want to do all that. We maintain sine square over cos square. So we say sine square theta over cos square theta. Whenever you divide numbers that are exactly the same, values that are exactly the same, so that will give us 1 over cos square. 1 over cos square is equal to what? 1 over cos square will give us sec. So since what we want to prove there is a sec, so we can change this one to become sec square. So this is sec square theta. When there is a square, there must be a square. When there is no square, there must be no square. Okay. So now we say we give this 1. Okay. For beginners, let's write this one first. Sec square theta equal to sine square theta over cos square theta plus 1. Then we can give this 1. Okay. So now sec square theta is equal to the LCM of any value and 1 is the value itself. So we say cos square theta. This into itself is 1. 1 times sine square is sine square. This into cos square is cos square. Cos square times 1 is cos square theta. So we say sec square theta is equal to sine square theta plus cos square theta. Sine square theta plus cos square theta is always 1. So this numerator gives 1 over cos square theta. See what we want to prove. If the question were like, prove that sec square theta is equal to 1 over cos square theta, this would have been our result. But it says just sec equal to 1 over cos. So this can be written as sec theta all to the power of 2 1 has a power of 2. In fact, one thing I like about 1 can take any value. 1 raised to 0 is 1. 1 raised to root of any value is 1. 1 raised to any value is 1. That is one good thing about it. 1 raised to negative half is just 1 again. Okay. So in that case, um, since 1 has a power of 2, and here again has a power of 2, so we can say 1 over cos theta. Both the 1 and cos, they have power 2. So from exponential equations, one term equals to one term where the powers are the same, then we can ignore them. So we say sec theta is equal to 1 over cos theta. So this is all what we have. Make sure if you are interested in copying, you can simply pause the video, then you can copy. So thank you for watching. Do not forget to like, follow, comment, and share. Please, guys, help me to just follow, then share so that others will benefit. Bye bye.